effect. How the trans isomer of this compound is prepared, how cis isomer of this compound is prepared, you might have studied, particularly the chemists. But this compound was prepared very long back in the early 1800s. But the structure was not known clearly. Only Werner in 1890s elucidated the correct structure of this compound. But late in 1960s, Rosenberg found its application as anti-cancer drug. So the cisplatin is used as a chemotherapy agent for treating a variety of cancers, for treating lung cancer, breast cancer, liver cancer, etc. Right? So, and followed by the use of cisplatin as drug, several cisplatin analogous compounds have been prepared, and also they found application as anti-cancer agents. Right? So the first application of coordination compound is in catalysis. Second application is in the field of medicine as drug molecules. Of course, the cisplatin is now the commercially available chemotherapy agent for curing cancer. The third important application, to understand many of the natural processes, you require knowledge about coordination chemistry. I've just given here the structure of hemoglobin. It is not the structure of full hemoglobin, the structure I have given in the left side. This is just one unit of heme. There are 4 such units in hemoglobin which are connected by means of a globular protein. You see there is an iron metal and which is surrounded by a porphyrin ring. In a complex, you have a metal, you have a ligand. The function of the complex is mainly centered on the metal ion. The metal ion does the function, whether it is a catalysis or it is a drug. Any application you see, the function is happening at the metal center. But the ligand tunes the property, particularly the electronic property of the metal, in such a way that the metal can function effectively. So here, if you take a complex and metal and ligand, no, they cooperate themselves, so they synergetically act whenever they apply somewhere. Here in the case of hemoglobin exists for a long time. You know, if you know when the first human was born, on that day this compound was born. So on that day this coordination compound was also born. It is not that the coordination compound exists only from 1893 after Werner predicted the structure. Werner predicted the structure only in 1893, but this compound, the coordination compound, exists when the human was born in this world. Right? So the age of the coordination compound is as many as the age of a human. But this may not be correct, because this is not the only coordination compound occurs in nature. If you take plant, there is a chlorophyll, particularly in green plants, that helps photosynthesis, and chlorophyll acts as a photosensitizer. You have magnesium, and you also have a porphyrin ligand system in the chlorophyll. So the age of coordination compound is much higher than the age of human, because in the history of evolution, now it is thought that plant has been created first before the human being, right? So when the first plant existed, at the same day, on the same day, the coordination compound from that day, coordination compound exists in this world. So This is a very old chemistry and is a very old science to understand. Before Werner explains about coordination chemistry, none could understand the role of chlorophyll, the role of hemoglobin in the transport of oxygen. Not only these two, we have many metal-based enzymes in the human systems, in the animal systems in general, or in the plant system, whatever, right? To understand role of all these metalloenzymes present in the nature, you require the knowledge of coordination chemistry. You just see here, this is a very complicated coordination compound. Just to prepare a simple coordination compound, we do a lot of things in the laboratory. We do heat, we do stirring, no? So we add this, that. The procedure is very complicated. But if you imagine how these complicated molecules are synthesized within the human system, it is very amazing. You are not heating, you are not stirring. No, it is naturally formed. Even if there is a deficiency of hemoglobin, you are not taking hemoglobin, you are taking only iron, then iron, in the presence of iron, hemoglobin is in situ formed in the living system and helps in the transport of oxygen from lungs to every cells of the body for the production of energy. And how iron-oxygen bond is formed in the lungs, and how the same bond is broken in the cells. You require the knowledge of coordination chemistry to understand. So, the coordination compounds can be used as catalysts in industries. Coordination compounds can be used as drug molecules, and we require the knowledge of coordination chemistry to understand some of the natural processes. And because of this, still the interest in coordination chemistry is sustained, and many like me live along with coordination chemistry. I said already that metal does function. Ligand tunes the property of the metal in such a way that metal can do the function effectively. To prepare some of the complexes for some catalytic applications and also for biological applications, we have prepared and used this acyl thiourea ligands. If you look at this slide, you can see there are two different types of acyl thiourea ligands. It's very simple. This is urea, NH2CS NH2, and acyl group is substituted. So this is acyl thiourea, right? And here, instead of two substituents on this nitrogen, you have one substituent and one hydrogen. Because of that, this hydrogen involved in hydrogen bonding with acyl oxygen, that leads to a very stable six-membered cyclic structure, right? And the coordination chemistry of this acyl thiourea ligand is very interesting. Why? Because this exhibits a variety of coordination modes. You cannot predict the coordination mode of this ligand until you solve the structure of the complex you prepared. Some of the coordination modes are given in this slide. You can see the first one is the bidentate coordination mode or monoanionic bidentate coordination mode of the acyl thiourea ligand. The second one is monodentate coordination mode of sulfur. This is very interesting. Even in the presence of oxygen and two nitrogens, only sulfur is coordinated to the metal. This was mainly observed with copper because copper likes sulfur very much based on the HSAB principle. The third one is a bidentate ON coordination mode. Fourth one, bidentate nitrogen sulfur coordination mode. In the last one, the ligand acts as a bridge between two metal centers. O and S coordinated to one metal, and nitrogen is coordinated to another metal. So the ligand bridges two metal centers here. So these are all some of the important coordination modes. So there is a versatility in this ligand. When there is a change in the coordination mode, then the electronic property of the metal is changed, and subsequently the property of the whole complex is changed. I will explain you later. And the preparation of this ligand is very simple. Normally it is prepared from acyl chloride. Here benzoyl chloride is given, which on reaction with potassium thiocyanate gives acyl isothiocyanate, which on reaction with amines, we can use either primary or secondary amine. Here in all the examples I have shown secondary amines, right? So this leads to formation of acylthiourea. If you use primary amine, here instead of one of the substituents, you will have hydrogen. You have only one substituent and you have one hydrogen here. You can use any acyl chloride and you can change the group here, right? You can use any amine and because of that, you can change the substituent here. You can have alkyl substituent, you can have aryl substituent or anything. So the opportunity is more for tuning the ligand, by means of which we can also tune the complex so that we can make the complex suitable for particular application. Though this acylthiourea is known for a long time in the literature, see, I mean, before our report, right, maybe in 2014, no one has used or even prepared chiral acylthiourea ligand, right? So we have started this preparation from benzoyl chloride, and then instead of a simple racemic amine, we have used chiral amine here, R or S 1-phenylethylamine. If we use R1-phenylethylamine, we obtain R acylthiourea. If we use S1-phenylethylamine, we have obtained S acylthiourea. So we have prepared chiral acylthiourea molecules, and we have used these chiral acylthiourea molecules to prepare chiral ruthenium iron complexes. This is a very interesting ruthenium parathymine dimer, and this on reaction with these chiral ligands led to the formation of chiral ruthenium complexes. Of course, we have used different spectroscopic techniques and also XRD technique to determine the structures of these compounds. You can see here the single crystal XRD structure of one of the complexes we have prepared. This structure is called as a piano stool structure. You see that now this is like a stool. This is the seat of the stool. You have 3 legs here. 2 legs are occupied by 2 chlorine ligands, and the third leg is occupied by the sulfur donor of the acylthiourea ligand. So the structure is, it looks like a stool, so it is called as a piano stool complex. We have used this complex in asymmetric catalysis. Hope you must be knowing asymmetric catalysis, but I just explain you in this reaction. This is a very simple reaction, transfer hydrogenation of ketones to corresponding alcohols. This is very similar to MPV reduction that MSc students study. And this reaction enables hydrogenation of ketones to produce alcohols, but this method is preferred over simple hydrogenation using hydrogen gas. If you carry out hydrogenation reaction using hydrogen gas, and it is not so easy, you require sophisticated techniques to handle the hydrogen gas, because it is very unsafe to handle hydrogen pressure in the reaction vessel. But this reaction is very simple to handle. So in many industries, this transfer hydrogenation is adopted to prepare alcohols from the ketones. If you get the racemic alcohol from the ketone, then it is called simply as transfer hydrogenation reaction. These 2 hydrogens are transferred to ketone, so ketone becomes alcohol and this alcohol becomes a ketone. This is actually a redox reaction. No, this is reduced, ketone is reduced and alcohol is oxidized, right? So we take alcohol in excess, particularly 2-propanol. So this acts as a hydrogen donor as well as a solvent for this reaction. But without the catalyst, this reaction will not proceed. The hydrogens cannot be transferred directly. You need a metal like ruthenium. So the ruthenium acts as a mediator. The ruthenium takes hydrogen from 2-propanol and gives hydrogen to this ketone. right? So without the mediator like ruthenium, you cannot take hydrogen from this alcohol. So hydrogen cannot be transferred to the substrate ketone, right? Now if you use the normal ruthenium catalyst, you will get racemic alcohol. But we are using here the chiral ruthenium catalyst. You see here, this is a chiral carbon, right, present in the ligand. So the whole complex is a chiral. When we use a chiral catalyst, then the chirality is introduced during the hydrogenation reaction, and we will get one of the enantiomers preferentially over the other enantiomer. What do you mean by racemic alcohol? If you have 50% R enantiomer, 50% S enantiomer, then it is a racemic alcohol. But here, if you use a chiral catalyst, you will get either R enantiomer 100% or 99%, or S enantiomer 99%. So one of the enantiomers is preferentially formed over the other. What is the importance of preparing only one enantiomer instead of a racemic alcohol? Many of the drug molecules that we use today are chiral molecules. Only one enantiomer does the drug action, whereas other enantiomer do not have any action in the human body. For example, L-DOPA is used as a drug for Parkinson's disease. Only the L isomer of the DOPA does the drug action. D isomer does not have any action at all. But even in some of the cases, one enantiomer is a drug molecule, whereas the other enantiomer is a poison to the human system. So you cannot take racemic mixture as a drug molecule. You have to isolate or you have to prepare the pure chiral molecule, and you have to administer as a drug molecule. So there is a need for the development of a catalyst for asymmetric synthesis. So we have used the chiral ruthenium catalyst here for the preparation of chiral alcohols. You can see here, in most of the cases, we have prepared all these alcohols, right? And only one of the enantiomers is obtained in these reactions. The conversion in almost all the cases, except the first one, in all the cases, the conversion is found to be very good. It means that, whatever ketone you take, almost all the ketone molecules are converted into alcohol. That's the meaning of 99% conversion, right? It means, and then almost all the alcohol molecules that are formed are of S enantiomer. So getting this much of enantiomeric excess or optical purity is not so easy in asymmetric catalysis, but we have demonstrated using this ruthenium acylthiourea chiral complexes. And this is the mechanism. We also have some proof for this mechanism. Initially, ruthenium alkoxide species is formed from the ruthenium catalyst and the hydrogen donor, and this ruthenium hydride species is formed from the intramolecular hydrogen transfer, and we have identified this compound by means of NMR and IR spectroscopy. This ruthenium hydride species interacts with the substrate to form 6-membered cyclic transition state. The interaction happens through ruthenium hydrogen and this N-hydrogen bonds. And this mechanism is very similar to Noyori's outer sphere mechanism. Some of you might be knowing about Noyori. Noyori received Nobel Prize for developing a very efficient catalyst for transfer hydrogenation reactions. And finally, when this intermediate interacts again with the hydrogen donor 2-propanol, the chiral alcohols are released. The chirality is induced here. Of course, there are some more the points how the chirality is introduced. I just omit at this point here. Right. Now, this is a very similar system. You just compare. Here, you have the tranosyl ruthenium complex and 2-chlorine. You have acylthiourea ligand. You have parathymine here. This is a very similar complex. You have 2-chlorine ligands, acylthiourea, but instead of parathymine, you have a benzene ring. A very small difference. And if you look at this mechanism, you can see There is no role for parathymine in the catalysis. This is what we thought initially. So we have prepared this complex and we wanted to apply this in the same asymmetric transfer hydrogenation reaction as catalyst, but we did not expect much improvement in the conversion and selectivity because the change that we made is not significant. Just this, normally we call this as a spectator ligand. Now the arene sits over ruthenium and see what is happening below. That's all. It is a spectator ligand. It does not involve in any of the functions, right? But when we have applied this in asymmetric transfer hydrogenation of ketones, we found very interesting result. That what is the interesting? That the efficiency of ruthenium benzene catalyst is very much higher than that of ruthenium parathymine catalyst. This reaction has completed in 14 hours, whereas here it took 24 hours for the reaction to complete. Ruthenium benzene is highly reactive. Not only that, just look at when astrophenone is reduced, we got S enantiomer when we have used parathymine catalyst, but when benzene catalyst was used, R enantiomer was obtained. It means you can tune the catalyst, you can obtain the desired R alcohol. If someone wants to prepare S alcohol, they can use parathymine complex. If someone else wants to prepare R alcohol, he or she can use benzene catalyst. It's very interesting. And we do not know how this happens, right? Reactivity as well as selectivity has been tuned by making a small change in the catalyst, by replacing parathymine by benzene. I have just compared, just to understand very clearly, after 14 hours, when parathymine is used as a catalyst, the conversion was only 46%, very moderate. And the enantiomeric excess is very, very low, only 16%. But when we have used ruthenium benzene as catalyst, after the same time, the conversion was 95%. So that gives you the activity of the catalyst. Ruthenium benzene is highly active, and then the selectivity is very, very good. So ruthenium benzene catalysts are highly active and also selective in this asymmetric transfer hydrogenation reaction. Why it is so? When we observe these interesting results, we should also explore what is the reason behind, this significant change in the activity and selectivity of the reactions. Here I have given ruthenium parathymine gives S isomer, ruthenium benzene gives R isomer, so there is a change in the selectivity. The reaction was faster with ruthenium benzene compared to the parathymine ligand, right? To understand this, we required collaboration. That is the main point here with respect to the title of my talk. As a chemist, I could not understand, because as per the mechanism that we have proposed based on the spectroscopic studies, right, the parathymine and benzene, they are just spectator ligands. They do not have any significant role in the catalysis. If that is true, then there should not be any change in the selectivity and reactivity, but we have observed a significant change in reactivity and selectivity. Now we sought the help of a physicist who can do quantum chemical calculations. This is the way, this is the field where chemists and physicists can actively collaborate. Many of the observations made by the chemistry researchers could not explain, but which can be explained effectively based on the quantum chemical calculations. So those who work in molecular physics can effectively interact with chemistry researchers so that fruitful results can be obtained. Okay, I just explained what are the results we have obtained based on the quantum chemical calculations. As I said, these calculations were not done by us. With the help of others who are specialized in molecular physics have done the calculations for us, but the results were very interesting at the end of the day, right? I just explained the benzene complex and then come to the parathymine complex. This is the transition state, right? There is an interaction between ruthenium hydride and the substrate. The substrate is nothing but acetophenone. You have phenyl ring, CO, CH3. When these two interacts, so the RUH and NH interacts with the substrate. That's what I told you in the mechanism that we have proposed. But not only these two interactions exist, there is another interaction, that is the interaction between the arene ring and the pi surface of the substrate. The CH of the benzene interact with the pi surface of the acetophenone. That is the third interaction that we could not find experimentally, but the physicists could find it based on their calculations. If this kind of interaction exists, it is called as a reface interaction. That is, if there is a reface interaction between transition state and substrate, that would yield S enantiomer as the product. And there is another interaction that is called a psi-phase interaction. If there is a psi-phase interaction, that would yield R enantiomer of the product. What is the difference between reface and psi-phase? Similar to reface, here also the ruthenium hydrogen interact with the substrate, right? And then instead of, right, similarly the NH interacts. These two interactions are common in both the transition states or in both the intermediates. But here, instead of this interaction, there's no interaction between this benzene and the substrate. Instead of that, the CH present in the acyl thiourea interacts with the pi surface of the substrate. So this kind of interaction is called as psi-phase. So whenever you have reface interaction, you would get S alcohol. Whenever there is a psi-phase interaction, that would lead to R enantiomer of the alcohol during the hydrogenation or transfer hydrogenation reactions. When you compare these two, the energy of this transition state is less compared to this transition state. It means this transition state is more probable, that can be easily formed compared to this. Because of that, now we concluded that psi-phase interaction happens when we use the ruthenium benzene catalyst. Because of the psi-phase interaction and the product, the configuration of the product alcohol is R when benzene is used as a catalyst. Very interesting, no? So, right, in the case of parathymine complex, similarly, two interactions are possible. The reface interaction is given here. In the reface interaction, the CH of the parathymine interacts with the pi surface of the substrate. Similarly, there is a psi-phase interaction also. But during the calculations, they found that the psi-phase interaction, the transition state of psi-phase interaction is very, very unstable. It means it has very, very high energy, right? And because of that, psi-phase is not possible here. So reface is favorable. So reface leads to S enantiomer when ruthenium parathymine was used as a catalyst. Right. Very basic contribution, but very interesting. Here we could not understand why in one case S enantiomer is formed, why in one case R enantiomer is formed, but physicists could able to interpret, no, or could able to justify the experimental results that we have obtained. That was very interesting. And the third observation here is ruthenium benzene is highly active compared to ruthenium parathymine. Why it is so? Now you just see this energy. This is 24 kilocalorie per mole. You just look at what is happening here, not rephase. Psi-phase is actually happening. You just see the energy of this transition state. Definitely the energy of this transition state is less. So because of that, no, the ruthenium benzene catalyst is highly active that catalyzes the reaction at a faster rate compared to ruthenium pyrosamine complexes. So we could apply, only because of the collaboration with physics researchers, particularly with who are expert in the molecular physics and quantum chemical calculations, we could explain our experimental observation. So this is very important. That is the theme of my lecture, and that is the purpose of showing only this result in this presentation. So there are a lot of opportunities for collaboration or interdisciplinary research in coordination and organometallic chemistry. This is one of the examples, right? And then I told you the first application of coordination chemistry is catalysis. The second application of coordination chemistry is its use as a drug molecule for various diseases. Of course, I have shown one example, cisplatin, that is a drug molecule for cancer. Now we moved our application towards, or we move towards developing coordination compounds which can act as a drug molecule for cancer. Platinum is cisplatin is a commercially available chemotherapy agent for curing a cancer, but it has many side effects like nephrotoxicity and neurotoxicity. So because of that, now people is looking for some other metal complexes which are less toxic or which can cause only less side effects compared to cisplatin or platinum analogous, right? So in this line, the research in ruthenium complexes for its use as anti-cancer drug started in 1965. Ruthenium amine complexes have been tried as anti-cancer drug, and some modifications have been done. The neutral ruthenium amine complex has been prepared and used as an anti-cancer agent. But these ruthenium amine complexes were not that much effective. So for commercialization, you need a very effective system. And then ruthenium benzimidazole complexes have come into the picture. And this sodium, the salt of this complex, right, has passed few clinical trials, but still it is not active. And these two are ruthenium DMSO complexes. This imidazole salt of this ruthenium DMSO complex, which is commercially called as NAMI-A, has cleared the phase 2 clinical trial, but its activity is not as expected for commercialization. So some modifications are still going on. But after 2000, the ruthenium arene complexes have come into the picture. Several ruthenium arene complexes have been prepared. You see here, this is a very interesting Rapta C complex. The C indicates the signing here. We also have Rapta B, where you have a benzene moiety over a ruthenium. So these complexes have shown a promising results in anti-cancer activity, and they are undergoing clinical trials currently. So in this line, we have also used the ruthenium arene complexes as anti-cancer agents. Then what is the superiority of ruthenium arene complexes? Already we know it has been proved that platinum complexes are good anti-cancer agents. This ruthenium arene system has the same kinetics of, or the similar kinetics of platinum system. Why I talk about kinetics? Because the cisplatin that I have shown already, that doesn't function as such inside the body. We take it as cisplatin, but once it gets inside, it is converted into an aqua complex. One of the Cl- ligand is substituted by water. So there is a substitution reaction happening in the system. Only the aqua complex interact with the 7th nitrogen of the guanine base, and that leads to cross-linking of the DNA strands and inhibit the replication of DNA, right? So the kinetics of the ruthenium arene system is very similar to platinum. That is the advantage. And then the ruthenium metal has a very similar property to the iron. Already the human system has the significant quantity of iron in the form of hemoglobin, myoglobin, or in the form of some other enzymes. So it is not harmful. It already exists in the human system. So it is expected that ruthenium also will be less toxic. So it may have a less general toxicity. And high selectivity is expected. Again, with respect to the ruthenium, iron, the iron is highly selective. No, it takes oxygen and then during the transportation, it binds with a particular protein like transferrin, and iron is transported from one place of the body to the other place. And iron is selective and less toxic already in the human system, so it is expected the same thing. What do you mean by high selectivity? When we take the ruthenium complex or any complex as a drug molecule, it should reach or it should act only on the cancer cells, not on the normal cells. If it acts on the normal cells, that will lead to the side effect. So it should be selective. It should act only on the cancer cells. It should kill only the cancer cells, not the normal cells. So that is expected in the ruthenium iron system because of its similarity with the iron in the periodic table. And not only that, when this undergoes hydrolysis like cisplatin, right, one of these ligands will be replaced by water to form aqua complex. During this equation, the stability of the structure is retained due to the presence of iron. Because normally ruthenium complexes are very sensitive to moisture. You cannot do equation very easily, right? But there is a structural integrity because of the iron. At the same time, the aqua complex can be formed, which can interact with the DNA and subsequently kill the cancer cells. And with this background, we have prepared a similar ruthenium parathymine complex containing acyl thiourea ligand. And before we test anti-cancer activity of these complexes by means of MTT assay, again, I tell you the interdisciplinary nature of this part of the research work. We have synthesized the compounds and the biological activity is done by someone who is expert in handling cancer cells, particularly biologists. We cannot handle cancer cells. We do not have a facility. So biologists have helped us to find out the activity of these ruthenium iron complexes in different types of cancer cells. So that has yielded a very fruitful results for us. We have developed a very efficient anti-cancer ruthenium iron complexes. I will show you this was possible because of our collaboration with a biologist who can do MTT assay. So before we test anti-cancer activity, we do some preliminary studies in our laboratory. We see whether the complexes bind with DNA. We see whether the complexes can bind with protein. For the complexes to act as an effective anti-cancer agent, similar to cisplatin, it should bind with DNA. The complexes intercalate between the DNA base pairs, and because of that, there is a cross-linking of DNA strands. Only that inhibit the growth of the cancer cells, right? So we have found by means of different spectroscopic techniques, you can see here, by means of UV visible absorption, by means of the fluorescence, by means of viscometry measurement, we have found that the complexes interact with the DNA molecules or with the DNA, right? And we have also found that these compounds interacted with a protein. And why the protein interaction is important? DNA interaction is important because the drug action is mainly based on the cross-linking of DNA base pairs. So there should be interaction between these molecules and DNA. Right. Now, when we take these molecules as a drug, it has to be transported to the cancer cells. And how the drug molecules are transported? These molecules are transported through blood. How? And blood contains protein. the drug molecules bind with the protein and then it is transported through the bloodstream. So there should be a binding between these compounds and the protein. Then only these molecules can be transported within the human system to the point where there are cancer cells. So we have observed that these ruthenium-arene complexes not only have the DNA binding property, but also they have protein binding property. So after these fruitful results, and of course, the MTT assay has been performed to evaluate the anti-cancer property of these complexes, right? You see here A549 is a lung cancer cell line, this MCF7 is a breast cancer cell line. You can see, and this, you see here very interestingly, this is a normal cell. These values are IC50 values, right? This is the half maximal inhibition concentration of the complexes. These are all the concentration of the complexes. If these values are very less, it means its activity is more. You see here among all this data, this is the highly active. That is this complex, the complex having this substituent. When the R group is this naphthyl, then it shows the IC50 value of this 52.3. So this is a very effective complex against breast cancer cell line. If you look at this data, greater than 500 something like that, it indicates that these complexes do not act on the normal cells. It kills only the cancer cells because this is a normal cell line where there's no activity was observed for the complexes, whereas the complexes kills the cancer cells here, right? And similarly, now we have prepared a ruthenium benzene complex, and those complexes have also been used, against different cancer cell lines. And these two cell lines we have already used, and this is a liver cancer cell line, and this is ovarian cancer cell line. You see that here the value is 40, and this is very effective. So this complex is very effective against the liver cancer cell line, right? So we have prepared the complexes, but when we say about the application, and really the objective of preparing the complex is fulfilled. So we say about the application, we cannot say the application without our collaboration with the biologist, right? So as a coordination chemist, we can collaborate with the physics, we can collaborate with biologists, so you will get fruitful results. And again, this is our collaboration with biologists who can do the anti-Alzheimer assay. This is a ruthenium-arene complex containing thiazemic carbazone ligand, not acylthiurea, as we have seen previously. These ruthenium-arene thiazemic carbazone complexes can be used as a drug molecule for Alzheimer's disease, right? And how this Alzheimer's disease is caused? And this disease is caused because of the aggregation of this amyloid B peptide or amyloid B protein in the extracellular portions. Outside the cell, there is aggregation of this peptide. And because of the aggregation, this aggregation causes Alzheimer's disease, right? When we add the complex, this aggregation is avoided. That's what our observation. It means when these complexes can be, if it is administered as a drug molecule, and this will avoid the aggregation of amyloid B peptide, and because of that, Parkinson's disease can be avoided. You just look at here, this is a thioflavin T fluorescence assay. When you add thioflavin to the aggregates of amyloid B peptide, it will give a very high fluorescence. But when you add a complex, the fluorescence intensity is decreased. It clearly indicates that complexes avoid the aggregation of amyloid B peptide. When the aggregation of this peptide is avoided, then we can also avoid the Alzheimer's disease in the human system. So these ruthenium-arene complexes can be used as a drug molecule not only against cancer and also against Parkinson's disease. Right? So then, yeah. So here you just see, and I have demonstrated our collaboration with physics researchers. I have demonstrated our collaboration with biologists, and right. So here in this work we have collaborated with both, and this ruthenium dimer on reaction with this thiosemicarbazone has given is already in the. Can you see my slides? Hello? Can you see my slides?
Yes, sir.
Yes, sir.
Okay, fine. Yeah, good. And I mean, here you can see that we have obtained two different type of complexes. When this R is hydrogen, this mononuclear complex is formed. This is what I expected. When this R is a methyl group, this interesting binuclear system or this interesting binuclear structure was obtained. No, it is very interesting. There is a very small change, but we have obtained an entirely different product. We could not explain this. What is the reason behind this? And the physicist has done a computational study for us, and basically, initially, the monomer is formed. That is not dimerized in this case, but that is immediately dimerized when R is equal to CH3. Right. And you see here, this is the monomer when R is equal to CH3. When this monomer dimerizes, that requires very less energy. When this R is equal to H, then this is the monomer. So the dimerization of this monomer requires very high energy, significantly higher than this one. Because of the higher energy requirement, the monomer contains the hydrogen, or when R is equal to hydrogen, that monomer requires very high energy for the dimerization. So we obtain only monomer, whereas in the other case, the dimerization is easily feasible because of the less energy requirement. If you look at, interestingly, this dimeric complex, when R is equal to CH3, the IC50 value is very, very less, and this is very close to cisplatin. So we have obtained the efficiency that is very close to commercially available chemotherapy agent. And of course, this computational study we have done with the collaboration with the experts of molecular physicists, and this MTT assay we have done with, based on our collaboration with biologists. And I just skipped few of the slides as time is already 11:30, right? And we have modified the substituents in the acyl-thiourea, and the modification of the substituents influence the electronic property of the ruthenium, which subsequently affected the activity of the complex, and we have obtained, based on that, we have enhanced the activity of these complexes to higher level. You see, the value is very, very less, 7.7. I told you already, if the value is less, that indicates the higher efficiency of the compound, right? So the ligands can be tuned in such a way that a very good anti-cancer agent can be obtained, right? So here, and of course, from this work, we could understand we can design a very good complex based on the theoretical calculations, and the activity of this complex can be demonstrated based on our collaboration with the biologists. Right. I just show here the summary of the anti-cancer activity of the complexes that I have shown here, and the few complexes I just highlight here. You look at this complex. the activity of cisplatin against this liver cancer cell line is 21.5 micromolar, but the activity of our complex is very much higher because the value IC50 value is less. It indicates that the activity of this complex against liver cancer is very much higher than the commercially available drug. Similarly, just see here, and we have achieved the activity of commercially available cisplatin from this complex. And not only that, the ruthenium complexes are expected to possess less toxicity compared to cisplatin, but there's a long way to go before the commercialization of these drug molecules. I have shown here in some of the slides that I have presented here that the interest in coordination chemistry is sustained for a long time. Why I say long time? That the coordination compound exists from the day of a plant was born in this world. So this is a very old chemistry. Still, the young minds are attracted towards this field because of the lot of, opportunities for collaboration in this field, and based on the collaboration, many fruitful results can be obtained, maybe in catalysis or in the biological field. Similarly, I feel in any field of chemistry or in any field of science in general, if we collaborate with others, maybe in the same subject or in the other subject, right? And I'm sure the research work that you do will have a very great impact compared to the work that you do alone, right? So if I don't mention these names, this lecture would be incomplete. The whatever the works that I have shown here were done by these students, Dr. Mary Shiba, Dr. Jayalashmi. Both of them are working as assistant professors in college, and Dr. Haribabu, who is currently JSPS postdoctoral fellow in Tokyo University of Science. Sri Vidya is said to submit her thesis. She's still working in our group. I also thank the funding agencies and NIT Trichy for funding and providing facilities for carrying out this work. Once again, I thank the organizers for giving this opportunity. Thank you.
Thank you, Professor Karvembu. It is a most outstanding and informative talk you delivered about the coordination chemistry and its application, particularly in the field of the things like cosmetics and to understand the natural products, and also in the drug chemistry everywhere. The coordination chemistry is very basic, and in combination with other fields of the sciences, that means the integrated approach about with the coordination chemistry is more applicable and application oriented also. So this talk definitely will be more useful for the young researchers and also the people doing in the area of coordination chemistry. So I congratulate for your effort taken in this line, and now it is for discussion. The audience or the participants can raise the doubts or queries about the topic delivered. Now it is open for discussion. Hello?
Yeah.
Karvembu, you are in line.
Yes, sir.
Thank you. Thank you. From audience side, any questions? So if there is no question, then suppose if you raise the question, then you unmute your mic. I think there is no question. Then I call upon Dr. Rajesh Kumar, Assistant Professor of Zoology, to propose vote of thanks.
Good morning to one and all. Join with us for this research and development cell and the Dr.M.Aruchami Research Foundation have jointly organized a webinar on Research in Basic Science, a tool for national building. Myself, Dr. S. Rajesh Kumar, Assistant Professor, Department of Zoology. It is my privilege to propose vote of thanks on this occasion. My sincere gratitude to our respected and most distinguished President, Dr. M.Aruchami sir, for his blessing in each everyday activity. I extend my heartfelt gratitude to our most esteemed Honorable Secretary and Director, Dr. C.A. Vasuki Madam, who encourage and motivate us on all our endeavors. It is a great time for me to thank our most respected Principal Sir for his encouragement and timely support. I also take this opportunity to honor our most valued guest of this session, Dr. R. Karvembu, Professor of Chemistry, National Institute of Technology, Tiruchirappalli, for sharing expertise on coordination chemistry on opportunity for interdisciplinary research, for sharing his expertise with us a enlightening our knowledge on chemistry and their importance, they were to explain the topic this explanatory. I also thanks Dr. S. Baluswami sir, Dean Research and Development, Organizing Secretary for the support for this webinar. I also extend my thank to Dr. S. Kumari, Assistant Professor and Head in Charge, Department of Zoology, and Dr. K. Tenmuri, Assistant Professor, Head, Department of Botany, coordinators of this webinar. I am thankful to webinar technical team for providing excellent facilities for this program. My gratitude to all the participants who involved made this session more valuable. I once again, on behalf of Research and Development Cell, Dr. M. Aruchami Research Foundation, Kungunadu Arts and Science College, and my own extend my heartfelt thank to one and all present here and encourage to complete this session successfully. Thank you.
Okay.
Thank you, dear participants, and the esteemed Professor Karvembu, who delivered the lecture on coordination chemistry. Now, we shall move on to next lecture. The guest speaker is Dr. Manivannan, Dean, Faculty of Agriculture, and Professor and Head, Department of Horticulture, Annamalai University. He is going to deliver on the topic, the medicinal plant, the utilization and conservation of red medicinal plants, rare, threatened, and endangered medicinal plants, most useful at present in this juncture in the COVID period. So these kinds of the drug and the medicinal uses from the natural products that will be more useful. In this line, I think he is going to deliver the lecture. So now I invite Dr. Rekha, Assistant Professor of Botany, Kungunadu Arts and Science College, to welcome the gathering. Now, Rekha.
Medicinal plants heal more than the physical body. They help open our hearts, reconnects us with spirit, and guide us in developing respectful and joyful relationship with the natural world. Honorable President Sir, Secretary and Director Madam, respected Principal, Dean Academics, and my dear teachers, a happy morning to all. It is indeed a great pleasure to welcome you all for this webinar on Research in Basic Science, a tool for nation building, jointly organized by Research and Development Cell and Dr. M.Aruchami Research Foundation, Kungunadu Arts and Science College, Coimbatore. Just before we get started, I would like to express my gratitude to all of you who so geniusly helped us make this event come together smoothly. We could not have done it without you. Leaders are developers, team builders, imaginers, culture caretakers, roadblock removers, and inspirers. Their success depends on enabling the success of others. It's my pleasure to extend a cordial welcome to our Honorable and respected President Sir Dr. M.Aruchami, Kongunadu Arts and Science College, to this beautiful occasion. It is pleasant duty to welcome our beloved, honorable and respected Secretary and Director Madam Dr. C.A. Vasugi, Kongunadu Arts and Science College, to this important and historic occasion. For her words of encouragement and her able guidance has always encouraged us. I extend my warm welcome to our respected Principal Dr. M. Lakshmanaswamy and respected Dean Academics Dr. S. Madan Sankar, Kongunadu Arts and Science College, for this wonderful occasion. On behalf of Research and Development Cell and Kongunadu Arts and Science College, I heartily welcome to our today resource person Dr. K. Manivannan, Dean, Faculty of Agriculture and Professor of Horticulture, Annamalai University, to this webinar on Research in Basic Science, a tool for nation building. I extend my agreeable welcome to Organizing Secretary, respected Dr. S. Palswamy, Dean, R&D, Kongunadu Arts and Science College, to arrange this program with his sincere effort. I would like to extend a warm welcome to coordinators Dr. S. Binnukumari, Assistant Professor and Head in Charge, Department of Zoology, and Dr. K. Tenmoli, Assistant Professor and Head Department of Botany, Kongunadu Arts and Science College, for this occasion. I extend my cheerful welcome to all the participants of our institution and also other institutions for this learning occasion. Before we started this section, it's a great honor for me to introduce our today resource person, Dr. K. Manivannan, Dean, Faculty of Agriculture and Professor of Horticulture, Annamalai University. Dr. Kalyaperumal Manivannan is presently working as Dean, Faculty of Agriculture and Professor of Horticulture in the Annamalai University. He has passed his BSc Agri in the Faculty of Agriculture, Annamalai University during 1983 and MSc Horticulture and PhD in Tamil Nadu Agri University, Coimbatore in 1985 and 1995 respectively. He has joined as Assistant Professor of Horticulture in 1986 in the Indian Council of Agriculture Research Project on cashew at RRS Virthachalam for 5 years. He has standardized the softwood crafting in cashew. He is one of the breeder in the team for evolution of cashew variety 3 and cashew variety H1. He also served in the Indian Council of Agriculture Research Project on tuber crop at Tamil Nadu Agri University, Coimbatore, and evolved the variety CO3 in Keshava, All Indian Coordinator Rice Improvement Project on tree species in HRS Erkad, and evolved the Cinnamon YCD1 as well as Guava TRY1 at AC and RI Trichy. He has assumed his service as reader in horticulture at the Faculty of Agriculture, Annamalai University during 1996 and subsequently got elevated as professor and head during 2005 and served as HOD for 8 years. He was the first director of academic affairs from 2015 to 2018. To his credit, he has put up more than 30 years of active service in research and teaching as well as in extension activity of horticulture. He has organized one national seminar on medicinal plants during 2003. He has guided 50 MSc scholars in horticulture and 17 PhD scholars. He has published 16 national and 14 international research papers and attended 116 national and international seminars and conferences. He has also co-authored 6 textbooks and a chapter on rosal. He has handled research projects funded by Ministry of Coal for revegetation of ash pond of Neyveli Power Corporation, National Medicinal Plant Board, DST. and involved in a network project on conservation of medicinal plants with coordinator from IIHR. His area of interest including fruit crops, flower crops, vegetables and medicinal plants. He has visited Malaysia, Singapore, Thailand, Sri Lanka, Australia, Netherlands, Latvia, Austria, and Indonesia for participating in international conference and to have academic collaborations. He is also a life member of many research societies. Recently, he has been awarded with the Fellowship of the Indian Society of Ornamental Horticulture for the year 2011 and Fellow of CHIA New Delhi. Today, we are privileged to have an opportunity to listen to him this morning. On behalf of all gathered here, I welcome you, sir, to this webinar on Research in Basic Science, a tool for nation building. Also, requesting to deliver a lecture on conservation and utilization of RDT medicinal plants of southern India. Once again, I welcome to all for this webinar on Research in Basic Science, a tool for nation building, jointly organized by Research and Development Cell and Dr.M.Aruchami Research Foundation, Kongunadu Arts and Science College, Coimbatore. Using herbs in the healing process means taking part in an ecological cycle. Thank you.
Now I request Manivannan sir to deliver his lecture. Sir, are you in line? Hello, sir. Hello, sir.
Yes, sir. Are you hearing?
Yes, sir. It is audible.
Okay, very fine. Very good morning to everybody. Really, it's a great pleasure for me to join you all in this webinar, which is being organized by the organization Aruchami Foundation. And I have to thank Professor Paul Swami, who has contacted me and to present talk on the conservation and utilization of RDT medicinal plants of southern India, where we have got a very good experience on working on these medicinal plants from our university for more than 15 to 20 years. When we talk about the diversity of plant kingdom, it is very wide. We can call upon the hydrophytes, insectivorous one, hydrophytes, fungi, parasites, flowering, algae, gymnosperms, and so on and so forth. In this way, where we find the slide shall we connect the slide? Hello, sir. Hello.
Hello. It is audible, sir. You can connect the slides.
How about? Okay. Connection. Stop presenting now. Google whether the slide is there?
Yes, sir. You're visible, sir.
Yes, sir.
Slide is visible.
The slide is visible.
Okay. Thank you. When we talk about the global scenario, the biodiversity is not evenly distributed among the world, more than 170 countries. In such a case, the very small number of countries like Brazil, Colombia, Ecuador, Peru, Mexico, Madagascar, Zaire, Australia.
Sir, excuse me, sir. You open the presentation. One menu is there, presentation.
Sir, in your phone, what is your presentation, sir? Sir, you stopped your presentation.
Attachments, will share it. The problem. Sir. Attachment. Google Drive.
எப்படி சொல்லுங்க சார், லைன்லேயே சொல்லுங்க சார்.
அது மினிமைஸ் பண்ணணும். நீங்க சொல்லுங்க. எனக்கு அது டெக்னிக்கல் தெரியாது.
நான் சொல்றேன் சார், அப்படியே சொல்லுங்க சார். தெரியும் சார். நான் சொல்றேன்.
Is it visible now?
Sir, slide.
Hello.
Slide is not visible, sir. என்ன பண்ணா?
சார் பிரசன்ட் நோ கொடுத்து.
Oh.
மினிமைஸ்.
Just I wrote.
பிரசன்ட் நோ கொடுத்துட்டு அப்புறம் மினிமைஸ்.
சார் அந்த பிரசன்ட் நவுன்னு ஒரு மெனு இருக்கு, அதை கொடுத்துட்டு அப்புறம் மினிமைஸ் பண்ணிருக்கு சார்.
ஸ்கிரீன் கொடுத்து மினிமைஸ் பண்ணிட்டு
Just a
இல்ல பண்றேன்.
minimize.
ரெடி வந்துட்டாரு. அவர் வரணும். சார் ஒன்றும் இல்லை சார், நீங்கள் கிளிக் பண்ணலாம் சார். மேலே வரும் ப்ரெசன்ட் ஸ்க்ரீனை கொடுத்தா ஸ்டாப் ப்ரெசன்ட் சார். இல்லைன்னா ஃபோன் பண்ணி அவர் நமக்கு அனுப்ப சொல்லுங்க சார், நாம ப்ரெசென்ட் பண்ணிடுவோம்.
நமக்கு அது வரக்குள்ள லேட் ஆகும்.
உங்க இதுக்கு சொல்லிட்டாங்க.
யாருக்கு சொல்லுங்க,
நீங்க அப்படி கரெக்டா சொல்லுங்க. நீங்க சொல்லிட்டு அந்த மேல வந்து 3 கிளிக் பண்ணி நீங்க சொல்லிருங்க. அவர்
ஃபோன்ல சொல்லிடலாம்.
மேல கிளிக் பண்ணி அந்த 3 டாட் இருக்கு, அந்த 3 டாட் கிளிக் பண்ணீங்கன்னா
சார் இதுலங்க சார் அந்த மேல 3 டாட் இருக்குங்க சார் உங்க ஃபோன்ல. அத டச் பண்ணி நீங்க பிரசன்ட் ஸ்கிரீனா?
ஆமாங்க சார்,
பிரசன்ட் ஸ்கிரீன் ஒன்னு வரும் சார்.
அத பண்ணிட்டு
அத டச் பண்ணீங்கனா சார்
பண்ணிட்டு மினிமைஸ் பண்ணிடுங்க.
அத டச் பண்ணிட்டு அப்புறம் மினிமைஸ் பண்ணிருங்க சார் ஸ்கிரீன்.
பண்ணிட்டு அவங்களோட பிபிடி ஓபன் பண்ணுங்க.
பிபிடி ஓபன் பண்ணி
அதுக்கு அப்புறம் பிபிடி ஓபன் பண்ணீங்கனா வந்துரும் சார்.
சொல்லுங்க
சார்.
இந்த வரை இருக்கு.
இப்போ மினிமைஸ் பண்ண சொல்லுங்க.
ஹலோ சார். ஹலோ.
Yes, please.
Sir, if it is not possible, then you continue your lecture, sir. Even without slides.
It will be more lively. That's what I want.
சார் இந்த ஸ்கிரீன் மினிமைஸ் பண்ணுங்க சார், உங்களோட ஃபோனோட ஸ்கிரீன்
மினிமைஸ் பண்ணணுமா?
ஃபோனோட ஸ்கிரீனை மினிமைஸ்.
ஹோம் ஸ்கிரீன் வந்துருங்க சார். அந்த சார் இப்போ பிபிடி ஓபன் பண்ணுங்க சார்.
இப்போ பிபிடி ஓபன் பண்ணுங்க சார்.
கிளியர் ஓபன் பண்ணுங்க.
அது எப்படி ஓபன் ஆகும்? எதை கிளிக் பண்ணணும்?
பிபிடி எங்க வச்சிருக்கீங்களோ அதை ஓபன் பண்ணுங்க சார். ஓகே ஓகே. அந்த WPS சர்வீஸ். ஓகே
வந்துட்டது.
ஓகே சார், ஓகே.
Now it's coming.
Now it is visible, sir. There is another.
Fine. Sorry for the delay.
Only, sir. Take your own time, no problem.
Yeah. When we talk about the diversity, it is all very wide. What we can all call it as angiosperms, gymnosperms, algae, fungi, parasitoids, or flowering plants like that, and so on and so forth. Whereas in the global scenario, the biodiversity is not evenly distributed among the world's most of the countries, where we have got only in 170 countries. In such a case, the majority of the countries in which the biodiversity is available, we can say like Brazil, Colombia, Ecuador, Peru, Mexico, Zaire, Australia, Madagascar, and most importantly our own India, China, Indonesia, and Malaysia. The WHO estimates 21,000 plants species globally utilized, whereas in India it is only 2,000 to 3,000 plants. And around 74% of the 121 bioactive plants are being derived as drugs, which are very widely used worldwide. The number of plants used for medicinal purposes worldwide, we can just project it, whereas in China it is more than 26,000 plants, and medicinally utilized are 4,900 plants with a percentage of 18.9, whereas in India it is 15,000 plants, and medicinally 3,000 plants are used, which accounts for 20%, whereas in USA it is around 21,000, and the medicinally used are 2,500, where it is coming around 11.8%. And like that, we can go on listing for Vietnam, Thailand, Malaysia, Indonesia, Philippines, Nepal, Sri Lanka, Pakistan. In the global level, around 4.2 lakh plant species are available, out of which 52,000 are being used as medicinally valued one. And in these, 8% of the plants, which accounts for 4,000 in numbers, are threatened in nature. We only call them as RET plants, rare, endangered, or threatened medicinal plants. The medicinal plant wealth of India, when we look upon it, India is very rich in medicinal plant diversity and having the unique biogeographic position in the global scenario, where we have got very wide range of ecosystems, like the coldest place, which is Nubra Valley, minus 57 degrees Celsius, dry cold deserts, the Ladakh, whereas the temperate and subtropical regions or northwestern trans-Himalayan region, rainforest or Cherrapunchi, evergreen humid tropics of our own Western Ghats, which is the paradise of lot of medicinal plants, and also the arid and semi-arid condition is our own peninsular India, and the dry deserts of Rajasthan and Gujarat, the tidal mangroves in the Sundarban, as well as nearby our own Muthupet nearby in Ramnad district, and also our Pichavaram in Kadalur district. Whereas the islands, very popularly the Andaman and Nicobar Islands. The distribution of medicinal plants accounts for around 70% in the tropical areas. The western and eastern Ghats, Vindhyas, Chotanagpur Plateau, Aravallis, Terai region of Himalaya and northeast, around 30% in the temperate high altitudes, very few in the aquatic habitats as well as in mangroves. The world scenario, we can have a glimpse of it. The Indian forest cover around 64 million hectares, or 19.5% of the land area. The per capita availability of forest land is 0.08 per hectare against the 0.5 in the developed countries, whereas the world average is 0.64 hectare. The Indian subcontinent is a treasure chest of the biodiversity, you all know well, where it hosts a large variety of plants, one of the 8 important Babylonian centers of origin, and the crop diversity is found only in our Indian subcontinent. The total land area of 2.4% of the geographical area of the world, and also 8% of the global biodiversity, with an estimated 49,000 species are available, that in which more than 5,000 are supposed to be in endemic nature. The total number of threatened species, when we look upon, Malaysia is having the maximum number of 874, followed by Indonesia 476, Sri Lanka 287, whereas in India it is 282, and it goes on like that in various countries like China, Philippines, Vietnam, Singapore, Taiwan, Myanmar, Mauritius, Cambodia, Laos, Bangladesh, Japan, Pakistan, Hong Kong, Nepal, and Korea. In the case of endemic plants, India is having around 12, whereas in Philippines it is 25, Malaysia 14, and Indonesia 7, followed by China, it is 6. The first red data list of South Indian medicinal plants based on the report of IUCN version 2.2 is supposed to be the species like mostly important one is of Acorus calamus, Adenia, Hondala, Adadoda bedomi, Aegil marmellus, Eriva vici, Amorphophallus pionifolius, and the list goes on like that, whereas we can categorize them into vulnerable, endangered, extinct, or low risk categories. In the case of DD, it is data deficient, and EW means it is extinct in the wild. And when it denotes or it is of regional in nature. In terms of habits, we can have the pie chart of the plant species which are medicinally important. The mostly around 36% is meant to be as shrubs in nature, and 28% of herbs, whereas the trees occupy a range of 21%, followed by the climbers as well as other species. The distribution in major botanical families, you can very well see mostly of Fabaceae, Forbiaceae, Astraceae, Poaceae, Rubiaceae, Cucurbitaceae, Apiaceae, Convolvulaceae, Malvaceae, and the solanaceous species. These form the major part of our medicinal plants. When we talk about the utilization of medicinal plants by the ecosystem people, mostly the village people or the tribal folks, they are using the medicinal plants for treating most of the ailments of humankind, and 4,635 ethnic communities use more than 7,500 species or plants for human and veterinary health care. Both are equally important. The human health care as well as the veterinary health care is being taken care by using the medicinal plants. India has the oldest as well as the richest, most diverse cultural traditions in the use of medicinal plants, like the Siddha, Ayurveda, Unani, and whatnot. Need to mobilize the resources. That's why we have focused upon the national resources, where the essential to sustain priceless legacy of Indian people. Out of 4,000 species in South India, 2,000 are used in Siddha, Ayurveda, and folk medicine. Whereas in the Indian system of medicinal plants, they are being used in the preventive, promotive and curative applications. These are the three major important area where they use. And 5,000 units have tenure of around 2,000 crore rupees per year, which may reach 4,000 crores in, I mean, it would have crossed the 4,000 crores in 2010 itself, whereas the demand for the medicinal plant is increasing in the survival in nature is under very great threat. Even some of them have become the extinct in nature. When we show the use of medicinal plant well, the Ayurveda uses 1,700 species, the folk medicine around 5,000, that is 4,671, homeopathy 482, Siddha 1,121, Tibetan medicinal plants 279, and the Unani 751. Out of 4,000 in South India, 2,000 are used in Siddha, Ayurveda, and folk medicine. An example of uses of biodiversity by ecosystem people, some of the medicinal and other plants used by the Mahadev Koli tribes. This is an example in which medicinal use is of 202, veterinary use 109. As fish poison, it means they will kill the fish in the pond and pick it up for consumption. Around 23 for the pest control 51. Water purification around 3, wild edible plants 87, fodder plants 65, fuel 30, hunting purposes 3, and cultural and religious purposes it is 38. When we talk about the utility, medicinal plants utility, around 800 species are currently used in the herbal industry for large scale production of herbal formulations, whereas presently 15 to 20% are commercially cultivated and the rest from the wild. Around 72% of the collections involve destructive harvest from the wild because the parts used are roots, bark, wood, stem, and the whole plant. That's why we are going for a destructive harvest. In such a way, lot of medicinal plants have become very much threatened or endangered in the wild, because the tribes, they are not bothered about collection, and gradually it is getting vanished from the ecosystem. This is how we can classify. Take the whole plants, it is around 16%, and the bark alone means 14%, wood around 3%, stem around 6%, the seeds, fruits, flowers, leaves. The roots are mostly 29%. See, such a high volume is being used in the form of roots, so only it has got destructed in the wild. Then followed by the rhizomes, around 4%. As a source of livelihood, this is how the tribals depend upon the medicinal plants as a source of livelihood. In India alone, it is estimated that collection and processing of medicinal plants contribute to at least 35 million work days of employment annually to the tribal and the poor rural people, the majority of whom are mostly women. The collectors sell the raw materials to the variety of markets, that is village stalls to industrial traders. The potential renewable natural resources we can call the medicinal plants. That's how it is being gifted, and the conservation as well as the sustainable utilization must involve a long-term integrated scientifically oriented action program. That's how we have to go for. The pertinent aspects what we can aim at is the protection, preservation, maintenance, exploitation, conservation, and finally the sustainable utilization. That's how it is to be given the focus. In the case of over-exploitation of medicinal plants from the wild to meet the demand of the Indian herbal industry, which has annual turnover of about 300 billion US dollars, tons of medicinal plants are being harvested every year from around 165,000 hectares of forest area, right from the southern parts of Agathir Hills and between the Western Ghats as well as the northern parts of our Indian subcontinent. Then coming to the conservation, which is a very, very important aspect, why we have to conserve? Because we harvest very much, that is too much of harvesting, growing of the plants and protecting too little. This is how it has been projected, where we can classify the conservation into two different systems. One is of in situ conservation and the other one is of ex situ conservation. If it is of in situ, the ecocentric establishment of biosphere resource, the national parks, sacred groves, where the joint effort of the forest department and also a NGO organization called as the FRLHT, which is having the headquarters in Bangalore. It is doing a very yeoman service in preservation of the endangered, threatened, and rare medicinal plants. In the case of ex situ conservation, where we can go for the cultivation as well as maintenance, that's how it has been made. One is of botanic gardens and parks, for example, TVGORI, which is there in Trivandrum, and the long-term preservation in the seed bank or the gene bank, like the other one is of cryo preservation. The conservation of medicinal plants in its bicultural perspective not only implies the conservation of biodiversity, but also place an equal emphasis on conservation of the cultural diversity. See, this holistic Indian map focuses upon the rich diversity of medicinal plants in India, where we can very well see the southern parts of the Western Ghats side. It is of very great importance. The dotted places where the plant species are available, very large number. The field gene bank is being maintained in our Annamala University, where some of the important species on which I am going to give a very small exposure is being listed, like the Decalapis hamiltoni, Gloriosa superba, Salacia reticulata, Saraka asoka, Oryxylum indicum, Salacia chinensis, Holostoma aracodian, which has been found very rarely in Trollam range of hills. With the support of the Manoliminium Sundaranaar University, we have collected the other species from University of Agriculture Sciences in Karnataka, that is Saraka, Salacia, and other species. Whereas the Moringa cognizensis is Tiruchirappalli, the rabbit herbarium of St. Joseph's College. Embelia ribs of CMPR in Kerala. Embelia Gerium potum in IAHR, Indian Institute of Horticulture Research. Trichopus zelanicus TVGORI, Trivandrum. Homalomania aromatica, NEDFI, it is in Assam. We have collected over there, and we have got the collection assembled in our gem blossom collections. And the total accessions collected in the network project of RET medicinal plants. These are all the species, and around total of 374 plants we have collected in various plant species listed over there in the table. This is a collection from Kottakkal Aryavedya Gem Blossom collection, and the next one is from MS University, MS sort of Wayanad, MS Swaminathan Research Foundation, and the other one is of an organization from Assam. When we focus on some of the medicinal plants, I believe the very few important medicinal plants on which I am going to highlight is priority, like the Decalapis, Gloriosa, Holostoma, Aracodian, Salacia, Tinospora, Gymnema, Garcinia, Withania somnifera, and other species on which we have worked, or the Hibiscus darifa, Hebidesmus indicus, and Coleus vetiviroides. In the case of Gymnema silvestri, we have assembled the collections which are grown very wild, especially in dry forest areas of 3-4 districts in and around. We have found a lot of variations in the leaf size itself, the shape among the genotypes, and also the growing habit. Some of them are bushy in nature, and some of them are very much trailing. And few collections have got profuse flowering in our collection also, where we have analyzed the chemical properties, and the leaf powder which you see in the pocket is the leaf powder. This could be very well used for to an extent to stabilize, or rather I can say the sustenance of the diabetics in the early morning hours. In the empty stomach, this leaf powder could be taken up in the capsules, empty capsules, 1 capsule per day. It will stabilize the blood sugar level, and a lot of people have found that it is of better curing, or I mean the stabilizing the blood sugar level in the diabetic patients. This is the detail of this Gymnema silvestri, where the Sirukurunjan, commonly in Tamil we call it as Sirukurunjan. Its status is of endangered one, where it is used in Ayurveda, folk medicine, as well as Siddha. The common uses of the plant contain a large number of chemicals, especially the triterpenoids, which may have the pharmacological property, and the saponins. The constituent saponins have the effect of suppressing the taste of sweetness. That is an important aspect on it. The extracts from the plant are the subject of research into potential medicinal and industrial applications, where the habitat, it is open rocky slopes and rocky surfaces of dry to moist deciduous places, as well as the forests it has been seen. These are some of the collections we have maintained in the University Medicinal Plant Garden. And the next one is Decalapis hamiltoni, where the roots are very potentially used as medicinally valuable ones. Common name is Mahalikirang in Tamil, where the status itself is also again endangered one, used in Ayurveda, folk and Siddha medicines. The roots of the Mahalikirang is used in the form of powder and infusion to treat wound and bronchial asthma. That is more important. Tuberous roots are used as cooling agent and blood purifier also. The habitat, when we see that the open rocky slopes and rocky crevices of dry to moist deciduous places, or the forests, where we have got a great experience in collection of this species in the Perambalur district, in various places of Pachamalai, Malayalapatti, Chengatapatti, Arumbavur, Vepandattai, and Veeraru. These expressions we have collected. See how wild it has been grown in the dry jungle, and the root. That's how in the root we can see the roots are being compressed in between 2 rocky crevices. That's how it is to be extracted. The tribes, nearby tribes, they helped us to collect. You can very well see the tubers and parts nearby, the tribes of Pachamalai, who helped us to collect. The tubers, they would have weighed more than 3 kg around. But this is how they are destroying the entire creeper, what we call as the Decalapis hamiltoni, and harvest the roots. Then ultimately it got destroyed. Then again the pods have to burst out into seeds. They will fly over and settle down in various places, and when the rain occurs, then again they will germinate and they will grow into small plants. But this has got the threatened nature. The pods and seeds also, you can see how it burst out into the air. These are the seedlings we have germinated in our laboratory condition, I mean the greenhouse conditions, and again we attempted to grow them in the tubs of cement pots in our university garden. Then next one is we can go to the Gloriosa superba, which is called as Kanvali Kirang in Tamil. This is very widely grown. Again, various stages of Gloriosa superba. You can commonly call it as even the Kalappai Kirang. When the forked root tuber, you see it is looking like a plow. So only it is called as Kalappai Kirang in Tamil, and the pods as well as the seeds visible in the vine. These are the seeds which are very medicinally valued, and the colchicine is being extracted from the seeds. These are the various accessions we have collected, and the Vedaranyam is a major belt where we can collect it naturally available in the coastal swampy areas. This is again endangered, commonly used in Ayurveda and Siddha. The tuberous roots are useful in curing the inflammations, ulcers, bleeding piles, skin diseases, snake bite, as well as the baldness. It is also available in the sea level to semi-evergreen forest region. But now the species Gloriosa superba is very widely cultivated in Ero district, Karur district, and also in Perambalur as well as Ariyalur district, in between the cashew groves. But again, the marketing is a major problem where the price fluctuation is there. Per kg of seeds, it is around 400 rupees to the minimum and 1200 rupees to the maximum. It is fluctuating depending upon the requirement by the pharmaceutical industries. Then next one is the Holostema Adacodian. Again, roots are being used as medicine. This is commonly called as the Palaikirai, which is very vulnerable and is very regionally available. Holostema Adacodian, we have seen it, the roots and leaves are used in form of powder and juice to treat spider poisoning, fever with burning sensations. It is also found in the dry and moist deciduous forest areas. The picture where you visualize is the place in the upper side of the Kutralam hills, where it is finding grown naturally as after the fire of the grasses over there. We can find the sprouting of the seedlings in the Kutralam hills. Then the next one is the Salacia reticulata. Again, this is the species which is found to be rare, and we can commonly call it as Kadal Arinchal or the Ponkoranthi. These are the different names mentioned in Tamil literature also, commonly used in Ayurveda, folk and Siddha. The roots are used in the cure of diabetes, hemorrhoids, chorea, leprosy, skin diseases, wounds, ulcers, and liver disorders. The habitat is in open marshy forests of coastal region. We have found this species especially in the Vedaranyam region zone nearby the Kodiyakare. You can see the satellite picture in which we have identified some of the accessions in Kodiyakare, Vedaranyam, Neduncheri, and Nandupallam. These are the 4 locations we identified where we have seen the Kodiyakare Reserve Forest, the Ramarpadam, the foothills we have found in the highest point in the sanctuary of Kodiyakare and Vedaranyam. This is the Salacia reticulata, and the next one is the Tinospora sinensis. Again, this is being founded. Tinospora sinensis is the rare and endangered species, commonly known as the single kodi. The other one is cordifolia. First one is sinensis, the other one is cordifolia. This is found very commonly in the plains. The dried stem is alone used, where the chemical constituents is tinosporin and columbin, palmarin and tinosporic acid, which is used for the immunomodulator and hepatoprotective one. This is the stem is very bitter, astringent, sweet, thermogenic, and as well as the antiperiodic, what we call as the medicinal importance of this. This is again a vulnerable one, the single kodi. Then the next one is the Garcinia gummicuta. This is a substitute for our tamarind in the Konkan Valley as well as in Kerala. They use it very widely for the acidic purposes. That is, it is commonly called as the bridal berry as well as gomboj tree. Again, coming under the classification of endangered species. This is finding place in Ayurveda, folk as well as Siddha. Herbal medicine against cardiac diseases and for the weight management. So this will go for a reduction of the obesity. That's how it is being blended with even the juice of extract of noni. These two have a great blend, and they make use of it for reduction of weight, which is meant for obesity. This is also found in semi-evergreen and evergreen forest. Then the next one is Withania somnifera, belonging to the family of Solanaceae, commonly known as the Ashwagandha, coming under the classification of Ashwagandha, the endangered one, Ayurveda, folk and Siddha medicine. This contains many useful medicinal chemicals like the withanolides, steroidal lactones, alkaloids, choline, fatty acids, amino acids, and a variety of sugars. The leaves and fruits have very valuable therapeutic properties, where the root of Ashwagandha is the part mostly used in the Western herbal remedies. It has many properties, to mention very few. It protects the immune system and also helps to combat the effects of stress and improve the learning, memory, and reaction time, whereas it reduces the anxiety and depression without causing the drowsiness. That is more important, and helps to reduce the brain cell degeneration, stabilizes the blood sugar, helps in lower cholesterol, and also offers anti-inflammatory benefits, and also contains the anti-malarial properties, which enhances the sexual potency for both men and women. That's how it's called as the Amukaran cleanse in Tamil. Ashwagandha powder, root powder, is very potential aphrodisiac in nature. Then the next one is of Hibiscus subdarifa. This is again an important plant species of a Hibiscus group, where the calyces are utilized in this subdarifa, belonging to the family Malvaceae, commonly called as Rosalie. This again is an endangered one, used in Ayurveda, folk and Siddha. The infusions of the leaves or calyces are regarded as a diuretic, choleretic, febrile, and hypotensive, decreasing the viscosity of the blood and stimulating the intestinal peristalsis. That is more important. the pharmacognosics in Senegal island recommend Rosalie extract for lowering the blood pressure. The extract also decreases the rate of absorption of alcohol and the effect in the system, and is a very favorite remedy for the after effect of the drunkenness. Next one is Hemidesmus indicus, what we call it as Nannari in Tamil, belonging to the family Apocynaceae. The common name is Indian Sarsaparilla. It's again an endangered one, categorized as endangered species, used in Ayurveda, folk and flavoring agent. It's used to make beverages and also used in traditional medicine. That is more important. In the Ayurveda, it goes by the name Anantamula, and also known locally as Nannari. In Sanskrit means as the endless root. It is also called the false sarsaparilla. It is administered in the form of a powder and also infusion or decoction as syrup. It is one of the Rasayana plants of the Ayurveda, which is having a very high aromatic flavor preferred in this hot summer day. It's used in the sarbat, what we call as sarbat, to get the body cooled. The extracts from the root are used as a coolant and as also a blood purifier, and used in many forms, especially as a refreshing syrup, what I have said now, with the sugar and as also this is also served at most small refreshment shops of South India in the summer times. Then the next one is the Coleus vetiviroides. This is another important species which has got a very small presence in the pockets nearby the Poliron river banks. The roots, especially the roots, are being used in this case. It is again an endangered indigenous species, small succulent herb and with pubescent leaves, where the fibrous roots are strongly aromatic. It is antibacterial, deodorant, as well as having the cooling properties. Then next we can switch over to the some of the work what we have done in the species like the Lecalapis hamiltoni, Alpinia, Galanga, and these species has been taken up from different flavors and used for categorized the chemical properties were categorized in the laboratories with the help of other institutes like the Multimodal Sundaranagar University. Then in vitro active gene bank is also being maintained in the IHR, Bangalore, Indian Institute of Horticulture Research. The anatomical studies have been done again in Multimodal Sundaranagar University for different species. These are all the work taken up. So I wanted to give a small picture about the rare, endangered and threatened medicinal plants of South India, where we have done the work under the network project along with other associates from various institutions. Thank you. Thank you very much. Yeah. Hello.
Sir, have you finished, sir?
Yeah, just I have finished.
Oh, okay, fine, sir. It is most informative talk, and you listed out many medicinal plants and its their utilization, the ways of conservation, everything, sir. Actually, these are all the works carried out by you and your team in Annamalai University in collaboration with some other institutions. So very good work you have done, sir. It is very useful, I think, for the small participants who are doing work in the area of medicinal plants. So now it is open for discussion. So the participants may raise questions by you mute your phones. Mike.
Hello.
Yes.
Sir, nice presentation, sir. I'm Karthik from Kongoda Science College, sir. So my doubt is, people are using the medicinal plants like indigenous peoples, as well as the lichens also has that medicinal properties kind of available in the Western Ghats. So what kind of medicinal lichens available in Western Ghats, sir, and what is the conservation status of that?
Lichens.
Yes, sir.
Yeah, those materials are mostly attached to some trees, is it not? The lichens, actually.
Yes.
Commercial cultivation is not being done on large scale. They will collect the material from the trunks and they will proportionately blend in the formulations. On that aspects, we have not done any work on it.
Okay. Thank you so much.
Welcome.
Any other questions from participant side?
Sir, one more question, sir.
Yes.
Sir, what is the promoting schemes available in India which is happened to promote the medicinal plant practices which is practiced by the tribals, indigenous people?
Yeah, it's a good question. There is one organization presently called as the National Medicinal Plant Board, having the headquarters in Delhi, attached to the Ayush Ministry, coming under the Health Ministry. If you go to the website of this NMPB, in short form we call it as National Medicinal Plant Board, they are having a great network in various states, having the State Medicinal Plant Board under the control of the NMPB, and they are funding on a very large scale to promote selected medicinal plants, like even AMLA. They have categorized 32 medicinal plants on that list, and they are coordinating to cultivate, promote the cultivation, and also to explore the marketing of those medicinal plants, giving importance to the pharmaceutical industries. They will tie it up with. And also one of the another organization is the Directorate of Medicinal Plant Research. Previously it was called as the National Research Center, NRC. Presently it has been upgraded under the ICR system. DMPR is having the headquarters in Gujarat, Anand. You can also contact them.
Okay, thank you.
CIMAP is also doing a lot of job on it, CIMAP.
Yes, sir. And one more thing is the pharmaceutical companies, most of them steal the ideas from the tribals, which has the previously used by the tribals, like a biopiracy they did. What is the level of that, sir?
We should not sarcastically say that it is all being stolen. The traditional Indian traditional system of medicine is being well documented by again the Ayush Ministry. We could not avoid the perpetuation of the biomolecules which are available in the existing medicinal plants and to be exploited and produced in a large scale by the pharmaceutical company. It is only for the welfare of the mankind. That's how we have to focus upon. But the cost or the benefit reaches downstream may be meager. That's why there is a good example done by the TBGRI in Trivandrum. The Koni tribes, they were having one medicinal plant, what is called as the Arokya Pacha. It has been utilized for the production of a medicine. They have patented it, and the royalty comes to the Koni tribes. Very periodical nature. They have made a wonderful system like that by the TBGRA they have done. That's how we have to approach and establish the link between the pharmaceutical industry as well as the tribes where they have the proprietary rights on those medicinal plants.
Thank you, sir.
Any other questions? So if there is no question, then I call upon Dr. Soundararajan, Assistant. Oh, okay. Before concluding the session, I will read the report for the two-day webinar. So by considering the importance of basic science research in the technological development, a webinar on research in basic science, a tool for nation building, has been organized by the Research and Development Cell, Kungunadu Arts and Science College, and Dr.M.Aruchami Research Foundation, functioning in Coimbatore, to disseminate knowledge and scientific information among the students and the scholars. An organization is working here. So jointly we organized this webinar in the lockdown period. So 3 lectures have been arranged in this webinar. The first lecture was given by Batmanaban, a neuroscientist working in Singapore. He delivered lecture on the topic, the role of multimodal imaging in drug discovery, yesterday evening. So nearly 152 participants took part in the session, and he emphasized the importance of the autoradiography and its role, the PET analysis, and everything that is used for the modern drug discovery. And then today, the first lecture was delivered by Dr. Karvembu, Professor of Chemistry, National Institute of Technology, Tiruchirappalli, on the topic, the coordination chemistry. Actually, he described the contribution of Werner Wilkinson, the founders of the coordination chemistry. Wilkinson catalyst, he explained, and then the interdisciplinary approach in research. That means particularly in coordination chemistry, it need more interdisciplinary approach, he explained. And the application point of view, the coordination chemistry is much useful in things like cosmetics developments and in the drug chemistry, and also to understand the natural products derived, the chemistry of the natural products derived from plants and other organisms. And this is also participated by more than 80 participants all over India, and they got benefited in this line. The third lecture and the last lecture that has been delivered by Dr. Manivannan, the Dean, Faculty of Agriculture, Annamalai University. Currently, he is also the head of the Department of Horticulture, Annamalai University. So he lectured about the topic, conservation and utilization of red medicinal plants of southern India. So most needed topic, most potential area to work out in these medicinal plants in India. Since India is a mega diversity nation, we are having lot number of medicinal plants still to work out. So in this area he covered, so the distribution and the species richness of various red medicinal plants he described, and various life forms, the percentage of different life forms of medicinal plants available in India, that has also been well explained by Manivannan, and the conservation possibilities of the red medicinal plants, the new strategies, particularly the in situ and ex situ conservation followed according to the species, that has also been described by Dr. Manivannan. And then the species cultivation technology developed by Annamalai University Agriculture Department is also listed out by Dr. Manivannan, most useful and very useful contribution to the medicinal plant research. And he described the red medicinal plants like Gymnema, and then the Decalipes, Hamiltoni, and Vidania somnifera, the species of hibiscus, and many things, many red species he described, the uses, the parts used, the chemical composition available there, the medicinal uses, everything he described well. So actually, they are the works done by the department people with the leadership of Dr. Manivannan and others. So very good contribution, very good lecture, very much useful to others. So nearly 81 participants take part in this deliberation and got benefited. So all the 3 sessions, 3 lectures in this webinar in different areas of biological science and chemical science, definitely I hope they are useful for the young researchers to do their research in future. So most thrust areas they have worked out and well presented. So I appreciate all the 3 resource persons for their wonderful lecture. Similarly, I appreciate all the participants for their eager involvement in taking part in the sessions. So with this background, I invite Dr. Soundarajan, Assistant Professor of Botany, to propose vote of thanks.
Yeah, very good afternoon to everyone. The essence of all beautiful art is gratitude. First, I would like to thank Honorable President Dr.M.Aruchami sir, most respected Secretary and Director Dr. C.A. Vasiki Madam, respected Principal Dr. M. Lakshmanasamy sir, respected Dean R&D Dr. S. Palsamy sir, and the organizing committee of this webinar for giving me an opportunity to deliver vote of thanks. On behalf of Kongunadu Arts and Science College and my own behalf, I express my heartfelt thanks to the resource person of today's webinar session, Dr. K. Manivanan, Dean, Faculty of Agriculture and Professor of Horticulture, Annamalai University, who spared time from his busiest schedule to grace this occasion. The way he explained the topic conservation and utilization of red medicinal plants of southern India is exemplary. He clearly presented conventional and contemporary approaches to utilize and conserve rare, endangered, and threatened medicinal plants. Thank you for your very interesting and thought-provoking lecture. I thank CEO Dr. V. Chinnusamy sir and Dean Academics Dr. S.R. Madan Sankar sir for gracing this webinar with their presence. I am also thankful to Secretary and Director Dr. C.A. Vasiki Madam and Principal Dr. M. Lakshmanasamy sir for providing us with all possible support towards organizing this event. I also extend my sincere thanks to the organizing secretary of this webinar, Dr. S. Palsamy sir, Dean R&D, coordinators, Dr. S. Binukumari Madam, Assistant Professor of Zoology and Head in Charge, and Dr. K. Tenmali Madam, Head and Assistant Professor of Botany. In such a short time, you have made a best arrangements for this program. I appreciate the hard work of this organizing committee of this webinar. My thanks also go to the technical staffs for their constant support. I want to express my heartfelt gratitude to all the participants from our institution and other institutions. Thank you very much for your enthusiastic participation in this webinar. I would like to thank you all again for making this event a grand success. Thank you so much.
Thank you, friends, for your participation and contribution in this area of webinar. So now we can disperse.